Alex, I have two things to talk about before we kind of hit the show on the road.
Yeah, what
Hey.
we got?
We failed our New Year's resolution immediately.
Yeah, it's kind of my fault. It's mostly my fault. Stuff happens. Hey,
Oh well.
It was only like a couple weeks. I'm sorry.
It was only a week.
A week? Oh, yeah.
Yeah. So we're not too bad. It's not like 3 month hiatuses.
True.
It's just a week. And a couple of days, because we're recording on a Tuesday. It'll probably go out tonight.
Okay. We tried.
Part 2 is it's freaking cold.
Buddy, you are preaching to the choir. I was outside all day in it.
I'm in my house in my outdoor coat, a sweatshirt, and a long sleeve shirt, and I'm still cold.
Yeah, I didn't turn on my little heater that's up here in the loft area because / a storage area, as you can see the junk behind me. And I did not turn on my little heater. It doesn't warm it up a lot, but it takes the chill off, and I didn't turn it on because I'm like, oh, it's not too bad. I walked up here. I still got, you can see I have like my Under Armour long sleeves on and everything from work today, and I'm getting a little chilly. But I still got my wool socks on, so my tootsies are warm. So
It is a cold day. But Alex, I am Tyler. That is Alex. Welcome to Life, the Complete Story, as we are here every week, giving my little spiel on nature and everything, going through our through the phylogenetic tree. Now we've covered all the invertebrates already. We've covered fish. That took us basically a year.
Fish took a long time.
And we're here in amphibians. We've already covered salamanders. We're covering frogs now. So roughly, let's say 5 more weeks of amphibians, I'd say, give or take, because we still have, plot twist. We're taking 2 weeks on this group of frogs and probably 3 or 4 weeks on the next group, and then we still have 1 group left of amphibians to cover.
That'll be 1 week in its own.
Yeah, it's just Sicilians. But we will start as we always do with our nature in the news. Alex, we are talking today about the Ordovician mass extinction. So let me pull up my geologic time scale here so I can...
Yes, I will pull it up for the viewers as well. Listeners, we'll do our best.
So we are talking... Oh, you have a different picture than I do. We are talking the Ordovician extinction.
Down at the bottom. 443 to 448-ish million years ago.
So this would be the second great extinction?
Way before the dinosaurs.
Yeah. And basically, at this time, we had precursors to modern fish. They didn't quite have the fin structures we've talked about with lobe-finned or ray-finned fish. They were more just like hunks of bone and flesh that kind of wriggled through the water.
They were still fish. They just didn't look quite like fish that we think of.
Right. Well, yeah.
They looked a little different.
But a lot of the fish of this time had external armor, right? So we're talking
I think
Dunkleosteus
so, yes.
And
around that time. I think Dunkleosteus may be around that.
Don't ruin my thunder.
A little bit more recent than that. They were like late Devonian, but that idea.
And so this was published by the Okinawa Institute of Science and Technology, OIST, in Japan. Published on January 11th. I found this article before we postponed the episode, so bear with me on it because I haven't read it in 2 weeks. So their little synopsis is that about 445 million years ago, we had this dramatic transformation where glaciers kind of spread throughout the terrestrial part of the Earth at that time, causing what oceans we did have to kind of dry out because it was locked up in glaciers, causing about 85% of all marine species to vanish, which at that time, most of life was aquatic. We didn't have any, right? We didn't have any type of sporophytes or gymnosperms.
I keep talking and I'll look.
Okay, sure.
Sorry, I found it. Devonian was when so we really, we didn't really have sporophytes. There was not really any land-based plants
And the plants had to come first before the animals.
Yeah, so I think most of your land, like you start seeing a lot of plants and like terrestrial life on the image I pulled up. Like the late Devonian into the Mississippian, I think, is when you really start seeing terrestrial life begin.
Invertebrates, yeah.
Yeah, but in general as well, like terrestrial life period, because the atmospheric oxygen problem was solved kind of by like the algae and the phytoplankton that would have been present more than likely, but you didn't have like the big plants on land. Like when we start thinking like the coal forming deposits, a lot of those come from like the Permian, like around that. It'd be like the Carboniferous period.
Anyway, moving on. So our Ordovician extinction happened in two parts. Part A would be a mass freezing. So there was a time where it was relatively warm temperatures, and then we shifted rapidly to an ice age. So climates changed rapidly, which drained your oceans as they formed glaciers, destroying lots of marine habitats. And then millions of years later, which in the grand geological time scale is like a snap, those ice caps then melted and flooded the oceans with warm water. So you had high sulfates and nitrates and a whole bunch of other compounds.
Those shallow seas would have been very salty, and then they would have suddenly been not that salty.
Yeah. And the oxygen levels kind of flip-flop too. So the species that did survive and were adapted to that cold climate no longer adapt to the water.
It does say here, actually, in the article, if we'd have just kept reading further down, the land at that time was like your very simple plants, like your liverworts, probably your like your bryophytes, like your ferns and things like that.
Horsetails, bryophytes, things like that.
And like along the coastlines, you would have had some arthropods just coming out of, like, starting on land.
And one of the biggest things to come out of this extinction would be the beginning of jawed vertebrates. A lot of things at this time had mouth parts, but not a jaw.
At least not the way we officially having jaws.
Not something that hinges open and closed. But post-Ordovician, towards the Devonian, we were starting to get more of a defined jaw part, and that leads us to the question of, were the jaws there to fill a niche, or was the niche filled and then we diversified further, kind of like a Darwin's finches thing, if you think about it.
Yeah, I mean, it certainly would have been an evolutionary advantage.
But that's going to do it for today's Nature in the News. We will move on into our lesson. And today, Alex, our lesson is on the first half of Mesobatrachia. And we talked about last week a different group of frogs known as Archaeobatrachia. Those are your primitive frogs. So these are Mesobatrachia. Meso means middle. So these are like, have parts of both. Like more modern frogs as well as the primitive frogs. So nice little middle niche here. So as of 2016, we have 6 families, 16 genera, and 244 species, along with a couple fossorial families. Alex, you want to kick us off with our first group of the day?
Yes, sir, I can do that. So, of course, Tyler said they're Mesobatrachia. Our first group of the day will be Megophryidae, which are the known as the goose frogs. This is a large family of frogs native to the Himalayas and is going east into the Philippines, so that's Southeast Asia, encompassing over 300 species and 2 subfamilies. Very notable camouflage, as you can see in the picture I pulled up, that especially in the members that live in forest environments, that is so accurate that the skin folds on their backs and their arms and everything actually look like the veins of leaves. A lot of them look very much like dead leaves. They range in size from less than an inch, so fairly small, to around 5 inches in length. So they're small to medium-sized frogs. But I'd say 5 inches is on the larger end of frogs. The adults have paddle-shaped tongues, so they The tongues, I'm guessing, are kind of narrower towards where they like implant in the mouth, and then they widen out as they get towards the end of the tongue. And tadpoles can be found in a variety of waters, but most commonly in ponds and streams, like I'm sure slower moving streams that have like some of the like pooling. So that way the eggs don't float away if they're not stuck to something.
Moves on into our next group. We're going to be talking about Pelobatidae. These ones are your European spadefoot toads. They get that name because they use their hind leg, specifically kind of like a shovel or a spade, to burrow out like looser sandy soil. They are one genus with 6 species, so that genus would be Pelobates. Every other genus would be extinct at this point. They are found throughout Northwest Africa and West Asia as well, even though they're called the European spadefoot toads. They grow up to 4 inches in length, as Alex said. It's kind of your average-sized toad, we're saying. Not quite a behemoth of like a Goliath toad. They have squat bodies with smoother skin and vertical pupils. They are burrowing members, as I said, digging into those sandy soils. They use their back legs. They're using hard protrusions. You can kind of see in the picture Alex has pulled up, but not really.
It's kind of hard. I can see if I can find a better picture.
All members have free-living aquatic tadpoles, so once they're laid and hatched, they're on their own for the most part, not hooked up to anything else. Their eggs are laid in vernal pools. That being said, they have relatively short tadpole stages. They have to hatch, be a tadpole, and metamorphose before that pool dries up for the season. That being said, again, some tadpoles are cannibalistic, eating other members of the brood to help accelerate growth. So that brings us to our members. We have 6 members. I can't count. 5 members. Western spadefoot toad, common spadefoot toad, eastern spadefoot toad, Moroccan spadefoot toad, and the Pallas spadefoot toad. I feel like I missed one.
Did, because it said there's supposed to be 6 species.
Oh, Pelobates balcanicus, which I'm going to assume is the Balkan spadefoot toad.
Sounds about what it should be.
Yeah, so that'll be it for this group. Alex, you want to bring us to our next group?
Yes, sir. Our next group is the family Pelodatidae. These are the parsley frogs found in the southwestern part of Europe. The name comes from the type of species coloration. It appears to look kind of like sprinkled parsley. So parsley is kind of like a green herb or a spice, kind of leafy. So you can see in the picture I pulled up, the frog, it kind of has little green spots all over it. So it looks like someone sprinkled some herbs over its back. They're your typical looking frogs. They're close in relation to the European spadefoot toads and other megaphirids, but largely differ in appearance. So their actual coloration is a good bit different. They're not as strong in the cryptic coloring, typically browns and greens. They tend to be small, smoother skinned frogs, only reaching about 2 inches in length. There are more extinct species from this group that are known than the actual living species. And these are also, looks like one genus, the genus Pelodites. There are 5 members: the Lusitanian parsley frog, the Caucasian parsley frog, the Hesperides parsley frog, Iberian parsley frog, and the common parsley frog.
That's all the groups we had scheduled for today. Kind of a smaller episode. We'll cover the second half next week, but we'll move on into our recurring segments. I'll lead us off with my amazing species for the day. Today's amazing species is going to be the Nagaland Asian Toad. So, as the name suggests, it comes from Asia, specifically Nagaland, which is a area of, I believe, Myanmar. It's kind of like close to that border of Myanmar, China.
It's, I think it's kind of part of India, like where India surrounds Bangladesh and is on the edge of Myanmar. Yeah. So
it is.
A relatively
India.
More mountainous region, that northern part of India near Nepal, Bhutan, so part of the Himalayan mountain range.
These guys were assessed in 2020 and published in 2023. So one of the more recent assessments that we've covered so far. They're listed as critically endangered because they have an extent of occurrence of about 10 square kilometers in one threat-defined location, and there's a continuing decline in the extent and quality of its habitat. And they live around that 1,300-meter elevation point around the two streams. Yep, I'm not even going to bother pronouncing those stream names. Near the Woka district in the Indian state of Nagaland. It's likely to occur more widely than is known, and it's possible to live in Myanmar, but there might be an unconfirmed locality. For the purpose of the assessment, though, they only did the Indian records, which is that 10 square kilometers. They have a decreasing population trend. It's not common to begin with. And since 2007, there's been a host of different attempts to find specimens, although we haven't been unable to find any adults. We have found a couple tadpoles and more juvenile specimens. We collected one specimen in 2018, it says, although we're unable to collect any in 2020. And our threats are urban development, logging and wood harvesting, as well as other human interventions. So this is probably one of the first amphibians we talked about where chytrid fungus isn't like the main culprit of decline.
Yeah, usually that's like your number one factor.
But for the most part, it's a lot of agriculture and ecosystem degradation. And I don't see any like trade uses, and it is not in any areas where it's protected. So that is step one, is to get it in under a protected area. But now is our little deep dive on the Nagaland Asian Toad. Alex, what do we got for today's Most Wanted?
Yes, today's Most Wanted, we're getting completely away from amphibians, and we're going to go to something that is near and dear, well, not dear, but near to us, something that you see a lot of in the United States especially, that's been talked about, is the wild boar, feral pig, feral hog, whatever you want to call it. These are wild pigs. Feral swine is another way to refer to them as these are pigs primarily that were brought to the North America as food, as farm animals, and they escaped or were purposefully released to hunt them, and they have become a lot of a problem. Initially introduced with the first European settlers to America, the 1500s, and they have now become a major problem throughout at least 35 states, most prominently in the south and west parts of the United States. The population is estimated to be over 6 million, and it rapidly is expanding. And over the last few decades, the range expansion has exploded due to a lot of factors like climate conditions, as well as being moved by people, and as well as not really having natural predators. Because they are fairly large, you'd need something like, and because they travel in big groups, it's difficult for predators that are not used to handling groups like that to control them. And because they're large, like a pack of coyotes may only take one or two at a time, which is not, they can have litters upwards. Let me find actual numbers here for you. What the how many babies they can have at a time. Let me find it here.
Upwards of 6.
Yeah, I mean like a handful at a time. Like many pigs. Not shown. Tried to look on here. It's not really showing me in a quick look. There are some potential predators though, especially out in the kind of middle western part of the United States, like wolves, cougars, jaguars going south, the alligator in the southeast, as well as the black bear and the grizzly bear. but there are kind of some barriers for the predation. Much of that being is because they travel in large groups, especially, and they're fairly quick. Also, they're not slow, so there are. And the reason they're such an issue is because they absolutely destroy plants and crops to the point where they're not just a pest for nature, but as well as for farmers, just because of how much they eat. They're voracious herbivores, actually even omnivores, eating. They primarily eat plants, but they will eat like invertebrates, really small vertebrates.
Carrion,
yeah, things like that. And they're incredibly adaptable to a variety of climates, conditions, and they outcompete native species, native herbivores that kind of occupy the same niche. And so they're just a huge problem. The most common way that they are dealt with is through hunting and trapping is the biggest way most common way, I should say, to control their populations, using large corral type traps where the trappers will put bait inside these big corrals and the pigs will enter. Usually they're monitored by cameras, so that way with remote control gates that the trapper can see. They try to get as many pigs in it as possible, and then the gates will close, or even I've seen some where the whole trap actually, it's like a big fence that drops down, and then they're trapped inside of it, and then they are loaded up into trailers, or they're just euthanized right then, as well as hunting is a very big way to deal with them. Even a very American thing in areas like Texas, can actually hunt them from a helicopter, which is kind of wild.
So bad. I want to do it so bad.
It'd be wild. It'd be fun, but it's definitely it's pricey just because helicopters are expensive to operate. So it's kind of a one of those, like, people do it like that just for the experience. You still have to have a hunting license for that, but it's very difficult. They do have sharp teeth, sharp tusks. They can get, like you can see in the picture I put up, they can get thick fur coats. And they have a lot of cold tolerance because they have they can get very fatty, especially as you get further north into areas like Canada. And even they will actually even kind of fashion what are in Canada called pigloos, where they kind of use like cattails and vegetation like that to kind of form shelters in the snow. And here is the litter sizes. They can have up to 6 piglets at a time twice a year. So I think 12 pigs a year, roughly, if not more. I'm sure in areas where it's more, or I guess further south where the climate is a bit more conducive to them having more young at a time. As I said, 35 states, they've been found in the east as far northward as areas like upstate New York, West Virginia, Kentucky, throughout Appalachia, all the way down into Texas, where they're pretty much found to be in. It says 253 of the 254 counties. I'm guessing the one county is probably the Dallas-Fort Worth area, where it's just so urban. There's nowhere for them to go. And it says here, just in Texas, about $50 million of agricultural damage a year. I think that's just Texas. So extrapolate that crazy. To
35 other states.
Yeah. And they've been seen expanding into areas like Oregon, Pennsylvania, where we live. Although I haven't seen any or heard a lot about it, but I'm sure that there are.
I'm sure they're in Greene County.
That I don't know, but I'm sure they're there. Ohio, New Hampshire, and they also host to at least 34 pathogens that can be transmitted to livestock, wildlife, and humans. So they carry diseases, and there's just a huge problem that unfortunately there's not a lot that we can do about it.
Doing the best population control we can. It's just unfortunately not quite enough. Anything else to add, Alex?
That is all I have on them at this point.
All right.
They have even been known to attack people when they travel in their herds, especially with young. There have been over 100 documented attacks by feral pigs on humans since the 1820s, and with at least 5 of them being fatal attacks. So they are dangerous as well.
All right. I will take the reins back from you, and I will move us over
Yes.
into our From the Vault. I couldn't remember the segment name. It's back. It's yeah. But today's From the Vault is going to be Beasel Bufo, which is a genus of frog known as devil frogs or devil toads. They were first discovered back in 1993 by David Krause, found in what is now modern-day Madagascar in the Maevarano formations. So this is kind of like the most famous ancient frog.
A great picture. Just give you an idea of how big these suckers are.
So initially the thought was they had a snout vent length of up to 42.5 centimeters, which I think the snout vent length is the distance between the nostrils.
No, it is between the nostril and the cloaca.
The vent is the cloaca. Correct. I'm glad you're smart.
Yes.
I'm not.
So for those who do not know, the cloaca is a single-use orifice for excreting as well as, especially in the females, for reproduction.
Right. Correct. So the initial thought was that it was 42.5 centimeters from snout to rear. However, later studies have now decided that's not right, and they're about 20 centimeters in the snout vent length.
Still quite large.
Yeah, that's about the size of the modern African bullfrog.
That's just 20 centimeters is just under 8 inches long.
That's a large frog. They had large heads, as you can kind of make out in Alex's little artist rendition here. They're kind of their spot in the tree is kind of a bit hairy. We haven't quite nailed it down yet on where it is. Alex pulled up another picture that is kind of showing off its diet. They ate a lot of everything.
Yes.
Mostly juvenile dinosaurs and other invertebrates, insects, lizards, smaller crocodilomorphs, things of that nature. The bite force measurement is believed to be between 500 and 2,200 newtons. I don't know where that is on the scale of bite forces.
Is how many newtons?
It's between 500 and 2,200.
So that, for a human, the typical bite force ranges between 100 to 150 newtons from normal function up to about 700 plus for maximum effort. So about the same amount, the same bite force as a human. To put into scale, a lion has a bite force of about 1,800 newtons.
So they range from human to lion, 500 to 2,200.
Yeah, that's even higher. Yeah, higher than lions.
That's crazy. That's insane.
Yeah.
But as I was saying, their phylogenetic position is kind of hairy. Initially, in 2018, they were thought to be a distant relative of horned frogs in the group Neobatrachia, although in 2022, a study found that Boreobatrachus and Beasel Bufo were a clade formed outside of that. And now, in 2023, it's believed that there are a sister taxon of Rhinoidea australis, which is the northern snapping frog or the round frog of Australia. So it's believed that since it was found in modern-day Madagascar, it was believed to have originated before Madagascar split from India and before India smashed its way into the rest of Asia. If I'm reading it right. I believe that.
Yes.
Although that's still uncertain too. It's a relatively recent discovery in terms of fossils, I believe.
Yes.
93 is pretty recent, 30-ish years ago. But that's all I have for our From the Vault. Alex, I'll slide it back over to you one last time for our ecology encyclopedia. Alex, what are we talking about today?
Today we are talking about the ecology behind wildfires. So this is something we just kind of came up with, but it's actually, there's a lot of misconceptions about wildfire, and a lot of that comes from the 1900s with the whole Smokey Bear campaign. Only you can prevent forest fires. But the problem is wildfire has been happening long before people were controlling them, and they're attempting to control them, and it will be happening a lot longer after people are gone. And it's actually a good thing. So I kind of pulled up a bit of and a graphic here that kind of shows why fire is a good thing. There are a lot of different organisms that are adapted to fire, especially it depends on where the different climate that you're in, such as the Western United States, where you see a lot of wildfires, or even areas like Australia, but especially the Western United States, where there are actually certain tree species. One of them, the one that always pops into my head, is the lodgepole pine, where it actually needs wildfire to reproduce because their pine cones are coated in a very thick wax that needs to be melted off of the cones, and then the cones will open and the seeds disperse. So said wildfire can be a good thing. So typically, if you're starting with like an old growth forest or just a mature forest in general, you can see in the graphic here, those older forests tend to actually be less favorable to a lot of wildlife, especially like herbivorous wildlife, because outside of things like in our area, you have like oak trees that drop acorns, hickory trees with their hickory nuts, things like that. There's not a lot of things for herbivores like deer to browse on, not like grass and like softer, low to the ground vegetation. And then as well, you start getting into things in very old growth forests. You start getting like monocultures, where you see those later introduced species, such as like your maples, that are more shade tolerant. So that way, eventually over enough time, they actually start to outcompete the earlier succession species like your oaks and your hickories that tend to grow a little slower but live longer. But in that note of like oaks and hickories, especially oaks, they actually are more fire resistant than things like those maples, kind of some of those softer hardwoods. Of course, in the east, like the white pine, red pine, things that are not very fire tolerant. And what that does is when a wildfire comes through, primarily in history, primarily things like lightning in areas where they have volcanoes, volcanic eruptions, things like that would start wildfires. Now, they can be started by a number of different things. Car accidents, just fire, like a fire in general from like a house, someone being irresponsible, flicking a cigarette out the window on a super dry day.
Lots of anthropogenic causes.
Correct, yeah. Fireworks is a thing, or even on purpose by like forestry teams will actually purposefully set fires.
Controlled burns.
Yes, it's what they're called, controlled burns, because fire is a good thing. Actually, the Native Americans they called it like good fire is what kind of, I think, the way they referred to it. Don't quote me on that. I'm not 100% on that. But they would also purposefully set fires, and because it actually helped when the fires burn, and if they burn on their own, and they really go unchecked other than by nature, when it would rain and put the fire out, or it just burns up all the fuel that's available to it. What that does is actually all the ash and the burnt up material gets all those nutrients then are very quickly reintroduced into the soil. It kind of burns up that upper layer, like that leaf litter layer, so then you get a lot of fresh soil is now opened up, and a lot of those earlier succession and understory are kind of open, like very sun tolerant species that like that very full bright sun, then start to grow. And then a lot of those are those like flowering plants that give those food sources to your lower story species. You get things like bees and butterflies and beetles. The invertebrates will come and pollinate those flowers, and then you get birds that come or anything that eats those invertebrates, and that cycle kind of continues. And then over time, of course, if it's an area where it can grow like a forested environment, you start to get some of those trees that will begin to grow, your earlier successional trees that tend to actually have those good food sources, like those oaks, hickories, even like some birches in our area, pawpaw, I believe, which is the only fruit native, at least to Appalachia. Apparently it's very tasty. It's like, has a very...
Never had.
I've never had it either, but it supposedly is very good. It's I guess it's supposed to have like a citrusy taste, but like kind of the consistency of an avocado. I don't know. I'd like to try it at some point.
That off puts me.
Yeah, it may not be for everyone, but and then you continue the cycle. But when you don't have fire, like you can see at the top of the image here, you get those big mature forests. But then, really, the only time you get like an opening in the understory for sunlight is when a tree dies. But then those dead trees start to pile up, all that dead matter, whatever. You get more and more of that. So then when a fire does happen, it's actually even worse because there's so much more fuel available for the fire. So they're hotter, more dangerous. They spread faster. They burn longer. And that's why we do prescribed fire or controlled burns to A, prevent that, and B, allow for. It's also a good way for invasive species management because a lot of invasive species, at least in our area, are not fire tolerant, like Ailanthus altissima, tree of heaven.
Yeah, take that, tree of heaven.
Yeah, that's not very. Yeah, it's not fire resistant at all. Things like multiflora rose, even like smaller trees like locusts, bushes like bush honeysuckle, autumn olive, Russian olive, they're not fire adapted. So it's a good way to control invasive species as well. And like I said, clears that understory, allows those more desirable plant species to grow, which then helps the wildlife move in because then you get more of the native species that are growing, which is what the native wildlife prefers, and they appreciate that, and it's a good thing in the long run. It's something that nature's been doing for millions of years, and until the last probably 150 years, it was allowed to do that without. We really didn't do much about it, but in recent years, it is something that we've tried to stop, and now when fires do happen, it's that much more devastating. I know that just a quick little anecdote before I wrap up. A number of years ago, I visited Smoky Mountains National Park, which is in Tennessee, North Carolina, eastern United States, right in the heart of Appalachia. And you could see that part of the area, I think it was like 14,000 acres or something, had burned. Well, that area was where that fire had happened was. You could see all the dead standing trees that had burnt, but all that understory was so vibrantly green. It was pretty cool. You could see just kind of how nature takes care of itself. So very, very cool.
The beautiful part about nature is it doesn't need people to do its thing.
It's been doing its own thing for millions of years, and we've only kind of come back in to mess it up in some ways. We've helped in some ways, messed it up in others. But we're going to stay off of that soapbox.
Yeah, we'll wrap it up for you guys.
Yes, sir.
That's Alex over there. I'm Tyler. Once again, we want to thank you for listening, watching, however you intake us into your routine. Make sure to follow us on Spotify, YouTube, wherever you get your podcast. Really, at this point, we are available. Make sure to send us an email at Life Complete Story. Follow us on our socials on Facebook at Life the Complete Story and Instagram and TikTok at Life Complete Story. I want to say that we are since switching hosting platforms, we switched recently from Spotify to Riverside for hosting, and our numbers have just kind of exploded. And that was something we did earlier this year, and we're 20 days in, a little bit more, because I think we switched around Christmas time.
Yeah,
and we're really thankful for you guys.
Yes,
to say
incredibly
the least.
Thankful. This is kind of been more of a passion project for us than anything else. It's something we do for fun and because we want to teach you guys about stuff we're passionate about because we both went to school for this. Tyler has worked in it. I'm sure eventually you'd probably try to get back into the biological fields, and I currently work in forestry management, focusing on utilities, but like forestry management. So something that we're passionate about in our daily lives as well. So it's and we want to share that with you guys. So we appreciate you all. Share it with your friends, family. If you're like a college student taking a zoology class or something,
ecology, anything.
Feel free to share it with your friends, your classmates. If they can learn something from us, that's kind of a little bit of what helped us start this. Is when we were in college, we'd have loved something like this to be able to just have someone explain it to us a little more than just reading a book or looking it up. So, but thank you.
Alex, why don't you wrap us up how you always do?
I'll wrap us up. Like I said, thank you all for joining us. I've been Alex. That has been Tyler. And as we say at the end of every episode, keep on learning, learn something new. You'll never know what you find interesting. But until the next time, we will see you